our ambition is to really tackle the climate crisis head on, project by project. And we believe the certified passive house route is the very best way we can do that.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler, coming to you from a pretty chilly Auckland in New Zealand, and I'm joined this week by Zach Semke. How are you, Zach?
I'm good. Seattle is rainy today, but it has been beautiful the last few days. Beautiful spring.
And we've also got Mary James back with us. How are you, Mary?
I'm good in a little cool California here, but
getting warmer, heading into summer for you guys.
Definitely. So every cool day is a blessing as far as I'm concerned.
Yeah. Well, we're going to get pretty much straight into a fantastic interview. We're heading back to the UK this week, Mary, where you and Ilka caught up with Joel Callow from Beyond Carbon. So some really great stuff in there. So keen to jump straight in. But before we do, Zach, got a few people to thank.
Yeah, we sure do. I want to give a big thank you to Bewizo. Bewizo is our sponsor of the week, so they're making everything possible for us at Passive House Accelerator this week, including this episode of the Passive House podcast. Thank you too to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. And thank you to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thank you to our champion sponsors, Bewizo, Cascadia Windows and Doors, Icon Windows and Doors, Intuos Windows, LG Air Conditioning Technologies, Proseco, Source 2050, and Zender.
Awesome. All right. Well, I just want to, just before we do dive in, was paint a little bit of context here for London and the UK, what's going on over there, which you do get into in this chat with Joel, Mary, but there is a mention of Barratt, and for a lot of US and listeners outside the UK may not be familiar with Barratt London. They've been around for about 40 years, and they're one of the largest developers of homes and buildings. And this is similar to, if you just think of one of the largest group home builders or volume builders in your area, it's kind of as if that company has embraced Passive House, and that's the sort of the context here that Joel and his team, that's one of their clients, but that's just sort of setting the scene for what's going on in parts of London and the UK where there is regulation that's stepping up, but there's also companies who are really stepping into Passive House. So with that, let's jump in and have a listen to, this is Mary and Ilka and their conversation with Joel Callow of Beyond Carbon.
Welcome to the Passive House podcast. I'm Mary James, and I'm here with co-host Ilka Cassidy, and today we're talking with Joel Callow, building physicist and one of two founding directors of Beyond Carbon, which is based in the UK. Welcome, Joel. And can you just give us some background about Beyond Carbon?
Hi, Mary. Hi, Ilka. Thank you so much for having me on the podcast. Yeah, so Beyond Carbon are a UK-based consultancy. We are passive house consultants. Most of the time, we're also building physicists, heritage specialists. We love a bit of climate resilience and avoidance of overheating, which, believe it or not, in the UK, we still do have some problems with it. I know the American climate is a lot hotter in many parts. We do get some hot summers here as well. So climate resilience, building physics, facade optimization. So all the stuff you'd hope for if you want to deliver really high performance, sustainable buildings that are just a cut above the regulatory norms. Yeah.
Great. And you really zoomed into Passive House, right? Is that the majority of your projects now?
Yeah, I would say virtually all of our new build projects are Passive House certified. Not every single one, but we would certainly prefer that. And we think clients who've got ambition tend to want to do that. And our ambition is to really tackle the climate crisis head on, project by project. And we believe the certified Passive House route is the very best way we can do that most of the time. Our heritage projects and our other more specialist projects are sometimes slightly different in nature, but new build, yeah, definitely Passive House.
You look at carbon as a whole, right? Not just the operational carbon, but Passive House fits in quite well with that approach, correct?
Yes, it really does. So we do have a focus on whole life carbon as well, and we have some specialists in that area. What we tend to find is if we get involved in the project in the earlier stages, the pre-concept stage, then we can shape the buildings to be really efficient in form, which of course assists Passive House, as many of your listeners will know, but it also assists whole life carbon. Not that there's a linear relationship in most cases. As buildings get very tall, it slightly veers off, but on the whole, a better form of building, a more efficient form, has lower embodied carbon and therefore whole life carbon, as well as Passive House too. So that's not the end of the story, but it's good to get the start of the story right, and then you tend to get better outcomes later on as you go through the detailed design phases.
That's a really good point. If you get your envelope a lot more compact, that lowers the embodied carbon as well. So, and that's basically most of your work, right? You do very compact, very dense housing in London. And before we talk about that, because I'm really curious about all of the work that you do there, how big is your firm? Because it sounds like you have a lot of work that you're doing right now.
Yeah, we are at the moment 12 people. I think 9 qualified Passive House designers, something like that. I forget the exact number. But we are almost certainly going to be recruiting quite soon to just build that team out as the Passive House stuff goes large in the UK, and we trust in other parts of the world as well. Yeah, we'll need to scale up a little bit in our organization. So small
Yeah.
but ambitious.
That's great. Is it easy to find people to recruit? How's the education doing in terms of Passive House in the UK?
It's improving. The Passive House Trust here in the UK has very ambitious targets for upskilling the whole industry. I mean, I think they have a target of 1 million trained personnel in some form over the next, I think it's the decade. Don't quote me on the numbers. Well, I'm sure you're going to because it's a podcast, but it's a very ambitious plan of training, and that's really scaling up rapidly. So right now, yeah, recruitment is hard, and I think most companies that are working in this kind of area in specialist sustainability would say the same. We do a lot of our own in-house training, and that helps. But no, it's improving rapidly. And Passive House has been big in the UK really for maybe 5 years. I mean, it's a massive scale up in the last year or two, but it's been known for larger buildings for at least 5 years. So we're beginning to see people that have done 2 or 3 projects, big, decent, complicated construction projects coming through the pipeline. They've done that. They're trying to find a better job in a better organization and approach us. So it was very hard 5 years ago. It was hard 3 years ago, and we feel like maybe it's just starting to get a little easier. So fingers
That's
crossed.
great. Yeah, that's great. Tell us a little bit more about the work that you do, specifically in the London area, because that's a huge amount of housing units, right?
It is, yeah. So we couldn't believe it when we counted up the number of projects that we're working on. Some of them are at feasibility stage still. So I suppose there's a possibility a client could go, oh, actually, no, not Passive House this time. So we wouldn't want to promise it's definitely going to be Passive House until it gets through the system. But on that basis, we're north of 9,000 dwelling units, either in design at the moment or even on site in some cases as well. So, and that's just beyond carbon, and other organisations that we know of are working on maybe not quite that number, but certainly a large number. So we're estimating something like 15 to 20,000 in London at the moment. And bear in mind, we only built 5,000 in London last year, which was a terrible year. Like we're supposed to build 80,000 a year in London. So we only completed 5,000 last year, none of which were Passive House, bar maybe, I don't know, a few hundred. So to go from a few hundred to, let's say 10 to 20,000 is just an extraordinary jump up. Of course, they
Yeah.
won't all get delivered next year. They'll take 3 or 4 years to build out, but
Yeah.
more are coming online all the time. So we're ambitious for that to be a very much larger number in a few years' time.
Yeah, that is like incredible numbers. How did that happen? How did you do that?
Oh, wow. It was a long journey. If anyone says, that they did it single-handedly, that wouldn't be true. And that wouldn't be true of Beyond Carbon either. The other thing is if they say it was easy or quick, that isn't true either. So we had to do a fair bit of lobbying to the government organisations that are in charge of energy standards in London. The Greater London Authority, the GLA, oversees the planning process in London and is a very powerful and influential organisation. They ask for higher energy standards than a regulation or code would demand in the UK, considerably higher actually. And that's widely understood and known across the London market. So what we did was we realised gradually in working with Barratt, who are the largest house builder in the UK and one of the largest in London, that there was a way to meet and exceed all the regulations and code requirements that the GLA and the national regulation was putting onto developers in a more straightforward and simpler kind of building physics and engineering solution using Passive House. So Barratt, like others, had been getting frustrated with just layer after layer after layer of additional regulation, and they're all well-meaning and important. Let's avoid overheating, let's reduce operational energy consumption, let's reduce embodied carbon. We deplored all of those things individually. Let's make sure homes are quiet, let's make sure homes have great air quality. All of those things make brilliant sense, and you wouldn't pick any one of them and go, no, let's not have good air quality. But when you add them all together, maybe the regulators haven't entirely thought how each of those is going to relate to the others. And there's just ends up this very complex kind of web of regulation that the poor developer is trying to navigate their way through with the architect, the HVAC engineer, and so on and so on. So we looked at this with Barratt strategically, sort of stepped back from live projects and said, could we meet certainly all the energy and comfort regulations with a simpler solution? And after probably, it was 12 to 18 months of initial research with them, we concluded, yes, Passive House allows us to radically simplify the HVAC solution in particular. So we'd done the research, we'd shown that there was a simpler way to actually meet and exceed all the code, the regulatory requirements that Barratt were facing. Then the question was cost, and could we do it more cost effectively than they had previously managed? Actually, at the time in the UK, Passive House had a reputation for being expensive. And we didn't think that was a deserved reputation most of the time. But to take it to a scale that somebody like Barratt would deliver it on, we had to be sure that costs were going to be very equivalent to what they would otherwise have spent. They can't afford to spend more. That's not how the market works. They might want to, but they won't be able to compete if they do. So we then spent quite a while working with cost consultants, working with architectural teams, still offline. This wasn't live projects at this point. It was still a research piece. And we showed that our wrap, if you like, of building design and HVAC design and so on, the total product that was the building was actually so much simpler than what they had been building that they could afford to consider doing it. We then took that to the board. So this was the London Barratt board, talked through all of the issues with them, some of the challenging sticking points as well, but critically that it was simpler, more deliverable, better quality, a better quality product for their customers. And Barratt are very focused on the eventual purchaser and resident of their homes. They were confident that what they were doing here was going to be a better outcome for those folk. So they then just needed to be convinced that, yeah, the costs stack up. This is reasonable. We talked it all through their cost consultants and at board level. They looked it through and signed it off. And a few months later, they got themselves into a place where they were willing to go public with it. By that time, we were already working on their first live project, and off they went. So they went live April last year, April 2025. And they went very public, very loud, as large organizations do, which was great. And generated a huge amount of positive movement in the industry along the lines of, wow, well, if Barratt have really thought this through and committed publicly, well, should we be doing that as well? Says developer B and C and D. And the answer is yes, they should. And it works really, really well. And they are gradually doing so, which is why we're now sitting on, circa 10,000 dwellings over the next few years, which is great.
Well, that's such a success story. And I just want to go back really quickly to the beginning of the story where you're talking about policy changes and that there are basically these requirements that addressed all these issues that people had or, developers in the London area, which is noise, right? So it's always very loud. Then there is pollution in the city. And then overheating, obviously there's quite a bit of potential for overheating in these heat islands in the city. And then, all those requirements that were asking to address these issues became quite complicated until you put it into the Passive House framework. And then you could solve all of this. So I think that's quite interesting. And speaks a lot towards the passive house principles, right?
Yeah, very much so. One of the things that Barratt had actually asked us to do was figure out how to be climate resilient into the future as well. So in the UK, we have a regulation for homes to not overheat. It's called Part O. It came in 2022. Caused a lot of furore in the UK market when it arrived. In actual fact, it's not asking for future resilience, only for present day climate. And Barratt said, okay, great, we need to pass Part O. Could you look into it for us and tell us what would it look like if we did a 2050 typical summer? And we would like our buildings to be resilient to that kind of degree, not just to the regulatory minimum. And so Passive House helped us to design buildings that were not just fit for today, but fit for 2 or 3 decades time. And one of the very simple solutions there was, by the time you've minimized all the loads using Passive House, you've got this wonderful building that needs very little heating and cooling compared to a conventional building. It's not zero, as some people would imagine it was, but it is a much lower number than normal. So we could fit active cooling to our buildings, which is not at all common in UK housing. I know there's large parts of the States where you probably couldn't live in a house without active cooling, but historically we didn't put it into our houses because our climate was cooler. But as you mentioned a moment ago, the heat island in London particularly, but actually all of the south and southeast of England is now hot enough that summers are pretty uncomfortable without cooling, and it's a big challenge for regulators. So our Barratt scheme and the other things we're doing with other developers with Passive House tend to have a very low energy, small, active cooling system, which comes in the background via the air system. Again, that's unusual in the UK, and just means that residents are going to be safe and comfortable even in a heat wave condition. It's not air conditioning. It wouldn't, chill your house to 22 degrees. Sorry, that's Celsius. I don't know how to convert to Fahrenheit to normal room temperature. But it would keep you from being under heat stress, or even, there are fatalities in heat waves regularly in the UK. So it would prevent all of that, keep people safe and reasonably comfortable. But it was a bit of a break from the norm. Active cooling is as I say, it's coming slowly in the UK, but people are very resistant because they're worried it'll be very high energy and high carbon. And this solves that problem. It's not high energy or high carbon, but it does keep your residents comfortable.
So you alluded to these smaller HVAC systems. Mm-hmm. I'd love to hear some more about those, because can you elaborate on what that is? I'm not sure how available they are in the US, but I want to hear some more about them.
Yeah, thanks, Mary. So I don't know what availability you've got in the US, and I'd love to find out. A critical enabler of all that I've talked about so far was the development of these small, what we call exhaust air heat pumps. So there may be a different name for them in the States, I don't know. And simply put, those are a small sort of reversible refrigeration cycle heat pump that sits inside the ventilation unit. We call that an MVHR, or air handling unit with heat recovery. So you've got all your usual passive house heat recovery happening in your air handling system as you normally would. In addition to that, you've got a small heat pump, heating and cooling coils, and it takes either heat or cool from the waste airflow and puts it into the supply airflow of the building. And so it's like a kind of amplified version, an exaggerated version of the normal heat recovery that's passive across the plate heat exchanger. It does that, and then a load more beyond it. So to give an example, if it's taking heat from the waste airflow to heat the space, you get a refrigerated airstream coming out of the building. So my house has one. It's quite common for, say, maybe it's 5 or 10 degrees outside air temperature, so just above freezing point. My exhaust airflow is just below freezing point, -2, -3 degrees Celsius, because it's taken that extra few degrees of heat out of that airflow, put it into my house supply. And in Passive House world, that's enough to heat the building. So that little system, very, very small, just a kilowatt or so in capacity, is enough for a passive house. It wouldn't be enough for an ordinary house. And so you've got to be careful with it. But in the right context, and London Passive House apartments is exactly the right context, it's a perfect fit. Really, really small, very cost effective, and delivers cooling, hot water ventilation, as well as the space heating, all from the same unit. So much simpler and much more cost effective in a construction sense than large, complex systems.
And so this is all delivered, you said, through the ventilation air.
It is indeed. Yeah, and that's another move that's very unusual in the UK. So our typical pre-Passive House London apartment would have had a wet heating system, so 2 or 3 radiators in probably in every occupied room of the building, or underfloor heating in the apartment. It would have had heat coming from a centralized system, typically an air source heat pump on the roof of your apartment block. That's then piped down the building, centrally down risers, and then it comes to an interface unit in the apartment where the resident gets billed. They get billed for heat, and then the heat supplies their radiators, and then the hot water comes from that same system instantaneously as it's needed. They have a separate ventilation system that's their own, a little MVHR in their apartment cupboard, and they just pay for the electricity and the filters of their MVHR themselves, but they pay for heat from a central solution. And if they need cooling, that's an additional system again. So you've got 2 or even 3 separate systems, of which one is a large, complex, centralized system that requires management charges, a separate engineering and maintenance contract to keep it operating, a contract to bill the residents for their heat, and so on and so on. So for a developer, that's a complex piece of engineering and quite complex to install and construct as well. And contrast that with this individual box that goes one per apartment and just has an electricity feed to it, plus a cold water feed, and then delivers all of those services to the apartment within the curtilage of the person who owns the apartment. That's their piece of equipment, and they're responsible for it. They pay for the electricity, any tariff they want to pay for, they can get, so they can choose the most competitive tariff on the market. Contrast that with heat coming through to their meter. They have to get the heat from the provider that serves that building. It's a monopoly, and the value is not there in a monopoly. So it's a great service for the resident. They get much cheaper heat from that solution. And we think the cost of heat, hot water, and service charge is around £1,000 a year in a typical apartment in the UK, sometimes more, and it's down sub £200 in the Passive House exhaust air solution with a good quality tariff serving their electricity needs. So it's 5 times cheaper than the competitor in the worst case.
Yeah, it sounds like a real game changer, right? But it only works if you build towards Passive House standard, right? So I'm curious, what are the differences for you within these building envelopes to optimize towards Passive House to make a system like that possible? How would you describe your envelopes?
The Passive House building envelopes are a refinement of what was being done in London already. So London does have higher standards for energy performance than the rest of the UK does. And so developers and contractors were used to having to do a little better than they would do outside of the city. And so what we took what they were doing already, and we said, well, look, how can we tune this without introducing large extra costs? And what we found was that the thermal performance of the building envelope was quite close to what it needed to be already. So it was about tuning quality on site, ensuring that the contractors were delivering what was drawn became what was built, as opposed to some differences emerging during construction. The drawings, what was drawn architecturally was probably not a long way off what it needed to be. So the U value or the R value of the wall, roof, and floor weren't very different for Passive House than they would have been for our code compliant, regulations compliant buildings. But the quality of delivery is very different. And then the other 2 things that are really different are air tightness, which is a huge step up for the construction team, and the windows. So we were finding that everything else was tuning, but those 2 things were a step change. And so we had to convince developers and contractors that they could deliver air tightness, actually, that they weren't going to they were terrified, perhaps understandably, that this one critical issue, they were going to fall over on site, because of course it's a pass-fail test. We all know you do your air tightness tests, and if you don't get it right on the final air test, you're really in trouble. You don't get a Passive House. So they could see all this, and they were saying, well, what if we commit to this? What if we say publicly we're going to do it, and then we fail? We'll look terrible. And so we had to do a lot of work on how do we de-risk air tightness for folk. That's a big change. It's not normal in the UK practice to deliver buildings that airtight at all. How can we really de-risk it for them? We did a whole series of things about that. Some of it was product related, a lot of it was process related. How do we help them to deliver a quality process across their site, construction site, so that they capture air tightness as they go along?
And you also mentioned windows. So I'm curious, what's different about the windows that you're using? And also, you had mentioned in your talk precisely optimizing window and shading. And can you talk about exactly how you do that? Like what tools do you use?
Yeah, absolutely. As it happens, this week I've been doing that process on several London projects, and just had an architect in a meeting with me yesterday say, Joel, I've never spent so long optimizing the design of just one window type in my buildings before, as we've done on this project. And he was he was joking, but it was true. We've absolutely fixated on avoiding overheating. So how do we do it? Well, very close collaborative work with the architect for a start. So that's not something that's generally present in the UK industry, and I don't want to denigrate the whole industry. It sometimes is, but on the whole, architects are kind of expected to get it right without anyone really helping them. And of course, it's a really critical design issue. Window design, shading design, the size and shape of the windows, the orientation, and then the specification of them later. All of that adds up to really radically alter the overheating performance, the daylight performance, and of course the passive solar performance for Passive House as well. So with all of that in mind, it's a little unfair to expect the architect to just suddenly have all that knowledge to hand and get it exactly right. So we pile in there with them. We really commit to a collaborative, rapid prototyping kind of relationship with them over usually probably 6 to 8 weeks of rapid concept development of the facade. And then it slows down a bit and we carry on over a few months following that. But over that critical period of say 6 to 8 weeks, we're using our own design tools. So these are tools we've developed inside Beyond Carbon. They're based on and built around Passive House tools, but they are rooted inside the Rhino grasshopper sort of ecosystem, which many of your listeners may be familiar with. It's a very flexible, very technical system. It allows you to do a lot of your own visual coding, and that means you can craft your own sort of route through to solutions that you wish to. So we've brought the whole of the annual heat demand code from the PHPP into the Rhino grasshopper environment. And because we've also got very rapid solar analysis inside the same environment, all of a sudden we can, once the model is built, the energy model, the geometry is brought in from the architect, once that's all done, we can run iterations and optimizations for Passive House heat demand, solar performance, daylight performance, and so on in just a few minutes of processing time, sometimes a few seconds, depending on the exact question we're answering. And that the difference between that and a few weeks is just game-changingly different. So we can run through 4, 5, 6 versions of the building.
Yeah, that's a very, very good point. And also the decision making that architects are facing, right? That they do need to get answers fairly quickly sometimes. Do they have access to this kind of modeling environment within Rhino, or is that something that's only in your scope? Do they still have to like work with you through it, or are they in some ways for like a first round of decision making somewhat autonomous? Have you been able to incorporate thermal bridge modeling into that process as well? Because that as well is something that architects have to decide all the time, right? How much insulation here do I need? Does that work?
That kind of idea. But in the UK, it's absolutely definitive. So before you've got planning, the whole process is at risk because the planners could say no. They don't like the design of the building, or it doesn't suit the needs of the site, or they don't think you've done the landscaping well enough, or any other numerous possibilities could block the project and stop it. So at that point, you're all working hard and fast up to this deadline of a very complex submission of architectural drawings, energy calculations, and so on to the planning authority, so the local government authority. When they've signed it off, which typically takes 8 to 12 weeks, I suppose, then you've got permission, you're permitted if you like, and then you can crack on with the detailed design. So most of what I've said so far has really been the pre-planning part, so the concept design stage. Once we get planning, during which we will not have evaluated thermal bridges at all because the detail hasn't advanced to that point yet. Once planning's in the bag, then the team proceeds through into the detailed design before they bring a contractor on board to do the construction. And at that point, yes, absolutely, we would go to town with thermal bridging and we would evaluate and optimize. And again, the purpose here is to get the building to work to Passive House, but not to overperform. If Passive House pass is achievable, but you achieve it with just a small margin, that's great because you've not wasted any money going beyond Passive House into better than Passive House, which isn't really necessary. So yeah, we would take thermal bridges one at a time, typically, I don't know, 30, 40 two-dimensional thermal bridges and perhaps 5, 6 three-dimensional bridges. The latter, three-dimensional, takes place in Rhino because it's a really good geometry tool. The former takes place in an ordinary commercial software called Fixer, where we can do quick analysis.
Thank you.
That's basically when you're talked about cost optimization studies, basically that's what you're talking about, right? Doing how to meet Passive House without exceeding it.
Yes, exactly. Yeah. So later on, we're on maybe edging towards construction. So now we've got a construction team on board as partners. We're going right through the build design, our 1 to 10 drawings with the architects, and we're getting down to the nitty-gritty specification and detailing. Contractors involved, they're discussing it with us and saying, should we do this or do that? Architect is drawing their 1 to 10s. At that point, we'll have done a calculation and they'll say, oh, how are we doing on our performance targets, Joel? And we'll issue a weekly or monthly report saying, here's our Passive House performance. And if we're overperforming at that point, we will tune back the design until it's passing Passive House but not exceeding it. We might have fewer thermal breaks, for example, or we might find that we can choose slimmer or lower cost thermal breaks, or there might be other ways we can relax the specification. But the purpose is to get a Passive House pass with a great building that's climate resilient at the lowest possible construction cost.
Well, and that's also just a huge benefit of going through energy modeling, right? Because you are able to pull all these different levers rather than just going just with an R value that's prescribed or something like that. So
exactly.
So the energy modeling is really key to optimizing to cost efficiency for sure.
I think we would probably say that and a little more. We would say that certainly in the UK, the Passive House tool set is misunderstood as a kind of how we get to perfection tool, whereas we would say it's just the best value engineering tool possible because it's so precise. So the contractor says, can I omit this thermal break here, Joel? And rather than going, I'm not totally sure. It looks like it might work, and then you basically guess. No, you can measure it precisely, and you can say, if I remove that break or I change it from a 20mm packer to a 10mm packer, this is what will happen to the energy performance and the comfort and the surface temperatures in the building. We check it, we agree, actually that's sufficient now. And so they go, great, we'll move to the 10mm packer, and they save some money. Or in fact, we had an example of this recently where a mistake happened on site, and we had some thermal break materials that were sitting at the bottom of a foundation detail in the building, so quite early on in the construction, and they got omitted by accident. So the construction team were working around the site, They were doing a day's work, dropping bricks into a position on the foundations. We weren't on site that day because we're only there probably once a week or fortnight. And I had this frantic phone call from the contractor. Oh, Joel, we've missed out the thermal break material. We just put the bricks straight down on the foundation. Oh, this is a disaster. What are we going to do? And we went, oh, hang on, let's just double check. And we went back to our calculations. We measured them against the present performance of the building at that moment in Passive House. And with precision, two degrees of precision in decimal places, we said, actually, no, we can afford to omit that detail. It doesn't affect surface temperature. Our energy performance has enough margin in it that actually that particular thermal break is optional. Actually, it would have been nice to have it because we'd have had a little more margin on our performance. We can do without it. And they carried on having, otherwise they'd have had to pull up all their construction from that day and start again with the break material. And they were delighted that they'd managed to squeeze through with that. So we were a bit embarrassed we hadn't spotted it to begin with. We could have omitted that detail. We're normally really good at getting it right to the margin. But on that occasion we didn't, and then it proved to be a benefit at the end to the contractor. So we're really ruthlessly committed to Passive House, but not better than Passive House. That doesn't make any sense.
That's great. And I'm just curious what's the timeline for some of these Barratt developments that you're consulting on? Are any of them finished?
Very good question. So the Barratt is a large organization. They're large sites. So a typical site would be somewhere between 500 and 1,500 dwelling units. So they necessarily take several years to design and do the due diligence and get the contracting team resolved and sorted. And then they're typically on site for a couple of years as well. So from the moment Barratt says, let's do this, and they buy the land, to the point where the residents getting keys for their new apartment is probably, it's sometimes 4 years. So the short answer to your question is, Barratt have a couple of sites that have finished already, but are not their full low E certified Passive House, but on which they have implemented elements of it. For example, they tested air tightness recently on a project that wasn't Passive House, but they wanted to see how well they could do, and just in their normal processes, to see how close they were already. But their first Passive House low E, so low E is their brand, sorry, for Passive House dwellings. The first low E project, I think, will finish in 2028, and the keys will get handed over at that point. So it's a long timeline. There are other projects that are finishing already, but they aren't Barratt projects, and they tend to be a bit smaller. Yeah.
So in your talk, you mentioned that within these developments, there's like 1/3 of them are affordable housing, and the rest is like market rate that basically kind of subsidizes the affordable housing. So how does that model work?
You're probably asking me something that's slightly outside my professional specialist expertise area. And there's a very controversial issue in London at the moment because the developers are finding it very hard to subsidize to the extent of 1/3 roughly social housing. To the extent that I understand the model, it's broadly the case that the developer passes the social housing or affordable housing across to a social housing provider effectively at cost. So there's not really any profit margin for those units for them. So the percentage of them is really critical for the developer. If it's 30%, it's a big hit. If it's 50%, crikey, I don't think they'll be able to build at all. And just in the last few weeks, the Mayor of London has announced emergency measures because of last year's terrible housing build-outs, the 5,000 units we finished last year, and because of the issues in Iran and so on, that mean they can do, I think it's down to 20% affordable now, temporarily. So they're saying to developers, we realize you're struggling with costs. This is a difficult market for you. We want you to build great housing. We're going to reduce the subsidized housing to just 20%. I think that's how they're doing it. Even that's still quite a challenge because the cost of construction in London, not because of Passive House, just because of London, is really, really high and has been very challenging for the last few years. So that they've adapted it. But fundamentally, the idea is that somewhere around 1/3 of houses will go to a social housing provider and be either rented out to tenants or even purchased at an affordable cost by the social housing provider, who is effectively a partner with the developer.
Great, thank you.
Great. Well, I'm sorry to get a question for you that's outside of your realm of expertise. But I just want to go back to that for a minute. Are those developments implementing Passive House measures in the same way across all the buildings?
Yes. So I would say that the local boroughs in London, so the local government authorities, They are often working in partnership with the social housing providers as well, or themselves are providers of social housing. So you've got three stakeholders, if you like. You've got the developers, the private developers, you've got the social housing providers, and you've got the local boroughs themselves. And the boroughs and the social housing providers generally really like Passive House because they're very, very focused on what will it be like for the resident. And of course, social housing, affordable housing, is generally the poorest people in our society who often really struggle with fuel poverty. So we're all very concerned about that. And they're delighted when they get a better quality product built for them by a developer and available to them as social housing providers that mean their tenants will pay far less for their utilities, for their bills. So they're very pro it. I would say they've been not exactly a catalyst, but a strong advocate for the movement towards Passive House. And some of the early Passive House work in London 5, 6 years ago was catalyzed by the boroughs and their social housing partners to build better for social housing, really. And it's more recently, so a couple of years ago, that the private developers have jumped on that bandwagon.
Well, that's great. I mean, that is such a positive outcome of the work you're doing, I imagine. I mean, it's just the whole at-scale implementation of Passive House, just allowing so many more people to experience the health and comfort of a Passive House dwelling unit. It's really remarkable.
It's very exciting, Mary. We're realistic about the challenges ahead. That scaling up a whole industry very quickly is hard. We talked already about the training that's needed, and the Passive House Trust is very, very proactive on that front. But it's going to be a challenge for all of us in the Passive House community in the UK. We're going to be working very hard to train up new members of staff in our teams, to then go out and offer that training to contractors and construction teams, and so on and so on and so on. So we're really excited about what's happened at the kind of front end of this, with Barratt leading the way. We're really impressed with their leadership of that issue, but we're really conscious too that now the hard work starts of actually transforming an industry, person by person, one at a time. So yeah, lots to do.
Well, it's just very impressive that, and I think there's a lot of credit that needs to be given to your company or your firm to convince someone like Barratt to do that step, right, and become a role model as one of the, I think they're one of the biggest developers in the UK.
They are,
right?
they sort of vie for top spot with another couple of developers, but at the moment they are the largest house builder in the UK and one of the largest in London, but not the largest.
Yeah, so just a very good strategy to convince them, and now there's lots of others that can follow into their footsteps. Great.
Absolutely. And they have the scale to do this well. If they engage with their supply chain and they say, we're going to do Passive House, their supply chain jumps to it and gets cracking, because the last thing anybody wants who supplies products to Barratt is to no longer supply products to Barratt anymore because they didn't make the cut, So we've had a huge amount of interest from the supply chain, from manufacturers particularly, which we've then engaged with as Beyond Carbon. So I was going to say part of our work was advocacy to the government. Part of our work was R&D with Barratt and going through the technical due diligence of design and costing. And part of it has now been hugely detailed engagement with the supply chain. So, I mean, Mary asked a few moments ago about these compact exhaust air units. We've been to the factory in Denmark of our key provider of those. We've spent several years monitoring in situ systems that have already been installed in other buildings. We've got enormously detailed models of how their energy performance works inside the system box. We've done far more work on that single product than we've ever done on almost anything else in the past. And we've done that also with window suppliers, shading systems, ductwork systems to supply the air to the MVHRs, and so on and so on and so on. So we've really done a lot of R&D support to the manufacturers as well at the other end of this. So it's a whole chain thing. It's right from the decision makers in the boardroom to the government, the seat of power in government, to the guy constructing it, to the people that supplied the ductwork from their factory. And it all matters, and all of it needs to be optimized to give best value. So we're getting close to, I think, having optimized all the components in the building for Passive House, but there's still a few left we want to do a bit more on. And of course, next year we'll find some new ways to make it better. And I'll come back and say, oh, it wasn't optimal. Sorry, we got that wrong. Here's the latest, that we've improved since last year. So continuous improvement all the time, everywhere, with everybody, government down to factory.
And that supply chain effect is gonna, I'm sure, spill over outside of the London area into other parts of the UK. So congratulations on that. I mean, that's wonderful to hear about.
Great. Yeah, where London leads, hopefully the rest follow is the idea.
Great. Well, that's a lovely note to end on. And I really thank you for your time. It's been great talking with you and very inspirational.
Thank you for having me. It's great to be on the Passive House Accelerator.
And that was Dr. Joel Callow, who's the founding director of Beyond Carbon based in the UK. Fantastic interview, Mary. There's so much in there. What was the highlight for you?
Well, it's hard to pick just one because it's
Yeah.
this interview and the work that they're doing at Beyond Carbon is sort of what you dream about when you hope to see Passive House being adopted on a larger scale. And it's the same feeling I had when I interviewed Az Rashid, who was head of design for Barratt London. Just the transformation is remarkable, and the way that Beyond Carbon has been able to help move that forward by accelerating the whole process of how designers can check what they're doing with its effect on Passive House levels of performance is remarkable. And of course, supported by the policy, the regulatory scene in London at the moment. But, all of it working together.
What about you, Zach?
Yeah, hard to decide, but one of the really exciting takeaways for me was just the reminder of the impact that a developer like Barratt can have on the supply chain, and the just one of these another example of kind of the ripple effects of these first movers at all different scales, and the we don't always remember that that's the case, but the idea that all these different manufacturers and suppliers are going to be scrambling to step their game up and to provide the components and materials and services that high performance passive house buildings require. I think that's such a key piece of the industry transformation that needs to happen, and there's a really powerful leverage point that Barratt and Beyond Carbon and everyone involved is going to be, making happen. They're going to be levering that leverage point.
I guess I think that from me, a couple of things: rapid prototyping, and you've mentioned, Zach, that people like Ed May and others have talked about that, and it's been a point of discussion for a little while. But it seems that Joel and the team are really putting that into practice and working alongside designers really early on to do proper rapid prototyping at concept stage when they still have the ability to influence the design, including the form factor, and looking at not just the type of windows, but also the size and the location of windows, which is such an important aspect to the overall performance of the building, and really locking that in right at the start. And then value engineering. I often hear the term value engineering, and for a lot of people that means just taking things out of getting and I refer that to as cost engineering, really, because it's often when developers see the price come back and they say, well, that's not going to fly, and they just start pulling things out, and it's often the things that we'd like to see kept in, like the better ventilation or mechanical systems. So true value engineering is, I think, what Passive House and things like PHPP can offer when you're doing that rapid prototyping, because it is a genuine way of doing a cost-benefit analysis. I think Joel made some really good examples there, Mary, when he was talking about design decisions and saying, well, what if we change this? And that's a legitimate question of the model, because it'll give you an actual answer rather than it just being guesswork. And I think the combination of those two things of applying proper value engineering, using rapid prototyping with Passive House is a great design methodology. Do you have any other thoughts on any of that, Mary?
Well, building a little bit off of what Zach said about the the right equipment. I mean, the small reversible heat pump that works to help supply just a small amount of heating or cooling. And, it works because it's a passive house building. And, it's just so exciting to have the right piece of equipment now, which wasn't available on the market there, I imagine, not that long ago. Certainly not quite available here yet, as far as I know, although probably.
Yeah.
So yeah, it's kind of a positive cycle. And yes, going back to your point, people hear value engineering and it's always a negative, but in this case, it is such a positive because he talked quite a few times. He mentioned meeting passive house and just meeting it, like not trying to exceed it, but just meeting it for the right cost, because that's how you can scale.
Yeah. Yeah, I like that idea of what was the term that he used? Ruthlessly committed to Passive House, but not beyond.
Right.
And using that as the benchmark. And I've heard a few other people say that, that if you're going beyond Passive House, you're probably going too far, and you're adding costs unnecessarily. So it's a really good target to hit, but not overshoot, so that you are really optimizing the cost. Really great stuff. I feel like we're going to hear more probably from Joel and from Beyond Carbon, and also not just from him. It seems that they're putting some great things out into the world. And Zach, I mentioned that the work that Ed May's doing over at Reimagine and with the collective. This is we're seeing a lot of emerging trends here.
Yeah, absolutely. And it's being kind of supercharged with our access to agentic AI now too. And I think that's one of the things that's exciting about what Ed and Skylar Swinford and others are doing. Like Ed has developed a set of resources. They're essentially skills and plugins that you can use to enable the large language models to interact with Woofy Passive and PHPP and other modeling protocols in a rational and as error-free way as possible. So there's I think that's what I'm seeing is a community of practice start to coalesce and sharing best practice and these resources that can be, put into the cloud. Like there can be a canonical kind of plugin that can be in the cloud that everybody can access that allows you to make sure you can, make the handshake between these new tools and our existing modeling software. So it's moving. All of it's moving so fast, and I think speaking of leverage, back to Joel's iterative work at the very beginning. I mean, as we all know, that's a long-standing truism of the design process is that you have that massive leverage early on, and so if you can, rapidly come up with a bunch of different solutions and pick the best one early on, it's a lot of power. So cool stuff.
Yep. Excellent. Lots of cool stuff. And there's some other cool stuff coming up. What have we got coming up at the Accelerator and Reimagine in the next week or so?
Yeah, well, I want to call out the component spotlight, Passive House component spotlight that we have with Cascadia Windows and Doors coming up on Wednesday, June 17th. It's called Beyond Compliance, How High Performance Fenestration Supports Passive House and Large Building Decarbonization. So visit the Passive House Accelerator website to get information about that and join us.
Awesome. All right. Well, thank you very much. Thanks for listening in. Definitely check out all of the great resources over at Passive House Accelerator. And also, if you haven't already, join up Reimagined Buildings, because there's fantastic conversations always happening over there. Lots of resources, as Zach mentioned as well. Thank you very much, Mary, for bringing us that fantastic interview, and look forward to hearing more from that part of the world and beyond in the coming weeks and months. And we'll be back again next week on Passive House Podcast.